Okay, this is, you get the text. I will put a little bit of stuff on it, but if you ask me afterwards, I'll explain why it's in text, and you might find that interesting anyway. This is a look back at some of the history of the development of Dyadic and Dyalog. So we go back, thank you, I'll read it off this one. Okay, when we began, Dyadic already existed, and this is early 81, we actually started the division of the work on Dyalog. But so within Dyadic, Pauline Brand, who was a very interesting part of our history, so she had a sister who worked for Dyalog. And Pauline is a significant part of Dyalog's history. She was recruited from Atkins, where everybody else had come from, when Dyadic Systems was about 4 months old, so 1977. Using sort of Meredith Belbin's team roles, I suspect you mainly know those, she's a classic finisher. Dyalog had produced one of the really successful 8-bit processors of the late 70s and was looking to produce a 16-bit processor. APL was a significant requirement for computer offerings of that time, thanks to IBM, who'd been pushing APL like mad. The 16-bit processor was the Z8000, which was not to see the same success as the Z80. Still, the two sisters pulled the managements together and an investment was arranged. Okay, so at that point, Dyadic recruited John Scholes, who had been at Atkins and went to the European Space Agency, and then had gone and implemented APL for ICL, both for the 1900 machines and the 2900 machines. When it got to the stage of actually implementing Dyalog APL, I was placed in the team alongside John and managed by David Crossley. That's not the Morgan Stanley David Crossley, that's the Dyadic David Crossley. John and I were working in Dyalog's UK offices in Maidenhead, a riverside town west of London. This introduced me to a number of new things. I have to do it with the trackpad, which I hate trackpads. Anyway, this introduced me to a number of new things. Firstly, Unix, which Dyalog has chosen as its operating system. It was not until I read the obituary for Dennis Ritchie that I realized just how early we had got into Unix. So this is autumn 81. And secondly, screen-based development. Until then, my experience had been scrolling paper terminals. It's not quite true. At Atkins, I'd done a statistics and APL project that used Tektronix graphics terminals, which were interesting in themselves. This defined our environment. We had not had much choice so far, i.e. the team, that's what we were given. So the first choice was to use C as a development language. This was not obvious at the time. Dyalog had its own low-level development language, which was a serious contender. John Scholes thought C would open up possibilities for a more portable implementation, and this proved absolutely true. Most of the interpreter is still in C. Second choice was whether we were to implement a first-generation APL or a nested array APL. John Scholes, who had already implemented APL on some restricted hardware, ICL 1900, favoured just doing a first-generation APL. I and David Crossley pushed for a second-generation APL, and this was probably our most significant choice, but was made almost casually in an afternoon of discussion. This decision did not affect us for a while. We had code to write, and that code did not depend on it. I got on with writing the scanner, the bit of code that translates APL text into tokens. John got on with writing the parser, which is the bit of code that processes the tokens and calls appropriate primitives. He was also writing the memory management. It should be noted that the scanner was the first bit of C I wrote, and subsequent developers suffer as a result. Sorry, Silas. The parser wasn't ready yet, so I next coded a large primitive, quad FMT. What an interesting place to start. I'm still not very proficient at C. Sorry, Vince, who's not here. But he inherited the quad FMT code. The parser was now sort of operational, so I could code primitives. At this stage, we had to make a choice: boxed arrays or floating arrays. John's choice was floating. He had been following the discussions. We had documentation, the NAS Blue Book. Anyone know the NAS Blue Book? I did mean to bring one with me, but forgot it. We actually wound up implementing more of it than STSC did. We coded to the only documentation we had. So Paul Berry's IP Sharp book, brilliant, I might say. The NAS Blue Book and Xerox's documentation of their APL implementation. The reason we had Xerox's documentation was Atkins was using Xerox APL. Since we had nested arrays, we changed some of the inputs and outputs of primitives to reflect the fact that sort of an advance. I was coding 2 primitives a day on average, although the set primitives, membership, dyadic, iota, union, intersection, differ, all of that group, took longer as they used a common approach. And we had chosen to implement all of those, and I used hash tables for them. We ran out of code space. The Z8000, you had 64K of code and 64K of data. So I developed a way of using multiple processes to get more, using Unix pipes to pass arguments and results, or for some things, entire workspaces. Building on these led to the development of auxiliary processors, those of you who have ever coded those, as a means of customers being able to extend the language, use the same techniques. I could now use an innovative approach to paren copy and load one workspace into a process and pipe the appropriate bits back into the user's workspace. That's not the way it's been done in most implementations. There was a discussion as to whether to implement the user commands paren load and the like, or use just ordinary proper primitives. The Dyadic employees who were still using various APLs on a daily basis, because they were consultants, balked at losing the system commands, so we implemented them. At about this point, we had version 1 of Dyalog APL, which Phil Gosher could document and use our brown and cream colour scheme, I bought one, to produce the first manual. So some of you will have long memories and will remember that. Most of you won't. Right. Now we had an APL we could port. The first port was to a Gould, which was a 32-bit box, luxury. It also threw up a problem, the solution to which was useful later and elsewhere. The problem was that addresses were hard. 32-bit things had to be on 32-bit boundaries. 64-bit things, like floating point, had to be on 64-bit boundaries. On a 32-bit machine, all of our arrays started on 32-bit boundaries, so that wasn't a problem, but we had to juggle a bit with doubles. Later, the same approach was used with decimal floating point, which is 128-bit alignment, and vector processes, which I think are 256-bit alignment. Marshall did most of that, and I don't actually know. We proceeded to port to a lot of new machines. Manufacturers were putting Unix on just about any box they produced. And the manufacturers needed to tick the box that they had an APL, although they did not sell much of it. Talk to Pete about how that worked financially. I just kept flying around the world doing ports. Those days, it was easier to move me about than to move machines to me. We were still Unix, but then came DOS. Not the operating system on IBM 360, but the IBM Microsoft one on Intel 8086. The 8086 and 8286 were horrible, and we avoided them. For a while, we sold an add-on board that used NAT semi-processors and provided Unix and sensible addressing, but it was a high entry cost to add that board to your PC. Then came the 8386. It was a game changer. Sensible addressing, FarLap, which got DOS into 32-bit, and MetaWare Hi-C, which came packaged with a copy of Mark's Gospel, gave us a compiler. MKS Toolkit gave us Unix-like tools to use for our builds, and suddenly, well, not quite that quickly, we had a DOS product. Of course, we were an application that required multi-processing, so that we could do those tricks with paren copy and the like. DOS was no help, but the 8386 was. It was DOS, so we had low-level access to everything, and the 8386 had task swap segments, so I used those. Somewhere about then, we did QuadSM. This is still a good tool for green screen type applications, but few still do those. Pauline, Pete, and Adam Curtin drove that development and did a fantastic job. Those of you who've used it will probably agree. I had some experience with both the Atari ST and the Three Rivers ICL PERC, which were graphics boxes, and I thought QuadSM would have a limited life as GUI was coming. I got that both right and wrong. QuadSM is still used extensively by one of the largest customers. Then came Windows 3. Flat address space, and I could not use the low-level task swap facilities. Pain. Still, it did have some multi-processing. As a Unix guy, I thought it was horribly deficient, but we could work with it. Along came John Daintree, and he produced QuadWC. I largely ignored this, which was my mistake. The Windows object addressing was buried in a text left argument. Remember that? However, the demand was to bring it out of there and make it part of the language. We needed namespaces for that. We had adopted a Windows-centric view of the object hierarchy, the big dot smaller still, whereas I argued strongly for smaller still, picked from big approach. The existing left argument syntax from QuadWC won that argument. Still hurts a bit, and it made the scanner more complex. It had another implication that came later. Consider big index by index 1 dot small index by index 2, from which namespaces are index 1 and index 2 taken. The way John Scholes implemented it was that they are taken from the current namespace. If we'd have gone the other way, it would have been different. I'm not saying better, it would have been different. It was some time before John noticed that we'd done this without asking ourselves the question. QuadWC was interesting in that we had choices to make for the implementation. JD favoured writing directly to the Windows code. This would preclude a Unix implementation. There was something of a host of possibilities for doing similar on Unix as well as Windows, and I explored Qt, pronounced cute, a little, and there was Mosaic and WxWidgets. None really convinced us that they were a long-term investment. JD wrote directly to the Windows API, and the resulting QuadWC was successful. Our Unix versions continued to use our green screen QuadSM. As it turned out, Qt has been successful and long-term, so maybe we missed a trick. At about the same time, early 90s, along came the DEC Alpha, a serious 64-bit chip. I still enthuse about that chip, despite it being little endian and wasting silicon doing both VAX and IEEE floating point. It could have done 128-bit floating point instead of the VAX code. We did a port, but it always stood alone. We just pushed our types up to be 64-bit. There were, still are, issues with not being able to take a 64-bit integer to a 64-bit double and back without a loss of precision. For this point, we extended fuzzy comparison to include 64-bit integers. Development continued. Windows 95, Windows NT, I quite like that. On a non-technical aspect, we split the company. IBM insisted that if you sold P-series, which we knew a lot about because we sold them, you had to sell I-series, of which we knew nothing. We split and merged the P-series side of the company that knew I-series with a company that knew I-series. It broke Pauline's heart to do that. We have since dragged Karen and Andy back into the fold from that half of the company, but I think we've missed Pauline's skills. My son started a PhD, evaluating characteristics as emulsions were stirred, and they were using atomic particles to trace the stirring, and was using APL to throw very large Boolean arrays about. I realized he was going to run out of address space. I bought a second-hand Sun UltraSPARC, which was a 64-bit box, and sent an email at work to say I was going to do a proper 64-bit port in my own time. Pete contacted some customers to see if this was something they wanted, and crucially, would they sponsor it. He got the support, and we did the 64-bit port using my UltraSPARC and a newly purchased Intel machine to use the brand new XP64 for Windows. It was new, just about available. My son dropped out of his PhD following a cycling accident, but we had made what I think was a crucial development. It was much later that I realized that IBM mainframes were restricted to a 2 gig address space, and thus IBM's APL2 had that restriction. Being a Linux Unix guy, I should point out the restriction comes from ZOS. Should that be pronounced ZOS? Who's the Americans? How do you pronounce that? Anyway, ZOS, not the hardware. JD got into .NET in a big way, but it didn't affect me very much. It probably would if I was not retired, as it has now reached Linux, but not AIX. John Scholes did his Skunkworks Dfns project. Along with the Dfns workspace, this was a tour de force and a real boost for APL. The only issue from my point of view is the static referencing. I preferred programming with dynamic referencing. The static references has benefits with mathematical code analysis. When I wrote this, I said, is anybody actually doing that with APL code? Monday's papers, and some today, clearly say, yes, they are. so that I'm on the wrong side of history. The next development was a learning curve for me as I did QuadMap. The learning was about paging and memory layout. I could map a single page with our own pocket header, you know, those bits that John Daintree was showing, in front of the data that I had mapped. The learning I did for this was crucial for the work on shared code files. See my presentation from a few years back, it's still available. Roger Huey came and brought with him trains, yet another style of coding and loved by some. I was now old and decrepit, and worse, did not write much APL code, so I didn't catch the bug. I think my younger self would have done so. The last decision was taken when I gave a year's notice that I planned to retire at age 75. I had planned to cut to a 4-day week at 70, 3-day week at 71, and so on. This failed, as I realized that I might be able to cut my time, But the crap, all the email and general junk, did not reduce, so I stuck at 3 days a week. When I said I was to retire at 75, it was decided that I would spend a year doing internal presentations on the code. Ask the guys, especially Silas, if this has proved useful. He's picked up most of my code. It certainly caused me to do a lot of revision as I worked through the code that was, in some cases, decades old. JD, John Scholes, and I had been to Microsoft in Seattle during the .NET development. I was sent because Geoff thinks differently. I made it the main purpose of the code handover to enable... let me click this damn thing. I made it the main purpose of the code handover to enable the poor souls who had to inherit the code to be able to understand something of how different that thinking had been. And that's the end.